I am almost sorry that this course is nearing the end. I have spent so many hours doing research, writing a huge amount of examples, rewrite complete parts of this training, that it really felt like solving a puzzle. And now it's time to take all the puzzle pieces and put them together for our final example. A neural network to recognize handwritten numbers written in plain Python code. The first thing to do is specify the numbers of neurons and layers. And here it is. The input layer has 784 neurons that represent 28 by 28 pixels of the images. The hidden layer has an arbitrary number of 20 neurons. Perhaps I need to change this later, but we'll come to that if the network is not performing well. The 10 output neurons represent the digits 0 to 9. Let's start by defining the network in code. I will set the batch size to 400. I chose the batch size arbitrarily, just like the following learning rate. Now I create the dimensions for the network accordingly to the diagram we just saw. Now I can initialize the weights and biases. The weights and biases are initialized. Let's inspect their dimensions. That seems to work. Now I will create the softmax function. I'll copy and paste from the previous project. And do the same for the log loss function. Now we are ready to start the training loop. The training loops through the epochs, and then through the batches. The hidden layer is activated by the value activation function. and the output layer is activated by the softmax activation function. I'll calculate and print the cost just like in the flowers example. The cost has been calculated and printed 150 times. 3 epochs times 50 batches of 400 samples. Each batch showed a different cost, but the cost did not go down because there is no backpropagation yet. The backpropagation works exactly the same as in the flower example. I'll type without explaining. The network is complete. All we do now is loop through the test samples and keep a score of correctly guessed images. I let the program run and print the result here. As you can see, the network was able to predict with 85% accuracy. I let the training run a few times, and because of the random weight initialization, I get different results each time. The overall result is pretty impressive if you realize that an untrained network would be able to predict an average of only 10% of the digits correctly. And I'm curious, what do the images look like that were not predicted correctly? I'll print the samples that are not guessed correctly. I let the program run and print the result here. Here you see 4 images that were not guessed correctly. I can see why the system was confused with these numbers. With some more parameter tweaking, you can even improve the recognition. What parameters could be changed? You can add some epochs, change the batch size, use the full MNIST dataset instead of only 20,000 samples. You can change the learning rate, add hidden layer neurons, or even add a second hidden layer. But I'm going to leave this as an exercise for you, because I am happy with the result. If you do not get a good result immediately, remember that the weights are initialized randomly. They do not always lead to the best result. You might have to run the training a few times before seeing the results you like, or store and use the same weights each time you run the system. That was quite a journey. Let's see what we have learned. Bias on neurons. You have come to the end